x times x plus 3 to the second y double prime minus y equals 0. And then we just rewrite it in the standard form as the leading coefficient or the coefficient of the leading order is 1. So y double prime minus, well, we don't have y prime, right? We're going to write 0 times y prime, and 0 divided by anything, you get 0. And then minus 1 over x times x plus 3 to the second power times y equals 0. Then based on this standard form, the capital Px is 0. The capital Qx is negative sign 1 over x times x plus 3 to the second. And we look for the point that makes at least one of these two functions undefined. So we know we have x equals 0 here and x equals negative 3 there. Okay. Then we get two singular points. So we have x equals 0 and x equals negative 3 are singular point. Okay, singular point. And then based on the uppercase p and uppercase q, so the lowercase p is x minus the x0 times the uppercase p, and the lowercase q is x minus x0 squared times the qx. So then we're going to check one point at a time. At x as a singular point, x equals 0. So then the factor that we're going to use, which is x minus 0 or just x. So the lowercase p going to be x multiplied by the capital P. The capital P is 0, so going to be 0. So for the lowercase p is continuous everywhere. We're going to have to wait for the qx, which is x squared multiplied by the capital Qx. And we get negative, since the q is negative 1 over x, I'm going to write x squared and multiply by negative 1 over x times x plus 3 squared. Then simplify to have negative x over x plus 3 to the second. And we're going to check at x equals 0. X equals 0 doesn't make the qx to be undefined. So we can say both px and qx are analytic at x equals 0. And we summarize this as the point x equals 0 is a regular singular point. Okay, one point done, and another point like at x equals negative 3. For x equals negative 3, the factor we're going to use would be x plus 3. So the lowercase px form the same way, but it's good because the px is 0. So we still get the lowercase px as 0. And the qx as x plus 3 to the second power times qx. Then we should get, well, I'm going to write it again, x plus 3 squared multiplied by negative 1 over x times x plus 3 to the second power. Then we get negative 1 over x. That's nice. So the target is x equals negative 3. And x equals negative 3 doesn't make the function qx to be undefined. So same answer as the point x equals 0. So both px and qx are analytic at x equals negative 3. Then the point x equals negative 3 is another regular singular point.